Here's where we left off. So I've been hard at work, working on this robot, trying to get this robot together. And what does it do? It falls off the table. But as you can see, the neck is broken. There and there. This mouthpiece came off. Here it goes right here. This part came off. It fell a few times, but I'm not giving up. I'm determined to have a functioning robot. See, you sit. Let's see if I stand him. See, his head should come forward like this. It's not doing it on his own. Woo! Woo! Heard that crack. It struggles to bear his own weight. Broken joints and a broken beat, but it continued to fight. It fought on because it was determined to stand, because that'll be the first steps in taking over the first steps in becoming a new robot. What's up, boss? I gotta go somewhere else now. Because I broke this beak because I was playing with it and making it stand and sit, and then it fell off and boom, dropped down there. So I remade it. I removed the beak. So this is the new print right here, the new face. See, the buzzers was on the beak. This is the beak. I took these and I designed them to go inside the back of the head. So this is the new version of the back of the head. The buzzers are going to sit right there. I also redid the neck motor. This is broken, so I have to replace this real quick. I'm going to replace this with the bigger motors, and I simplified it. I removed another servo so I can focus on walking. I made some adjustments. I replaced the weaker servos with some stronger servos, etc., etc. But like the great philosopher Snoop Dogg once said, if it ain't one thing, it's a Snoop Dogg is the name, dog pounds the game. If it ain't one thing, it's... I've been working on this non-stop. I have two bad servos. I replaced a servo here. Then I ran into another bad servo, which is in this knee. You see it moves? This one doesn't. It's stationary, but this servo has a weak connection. It has a weak connection right here in this wires. See, if I tighten it, now it moves again. So I have a weak connection in this. I have to order some new servos, but in the meantime, I'm going to work on another robot. So this will be my third robot that I haven't completed. This is robot number 2 that I am going to be putting on vacation for a while until I get a new servo. So I have 2 robots down that I have to return to in the future. But in the meantime, I'm going to start working on something else. I have a ton of 9G servos, the smaller servos. So I thought I can try to make a mini version of this in the meantime and then come back to this later. I'm going to take all the things that I learned from building this and apply it to this new mini version. I'm not going to have all the things that this have. It's only going to have like maybe a screen attached to it, but a simple mini version of a robot to see if I can get that completed. That's going to be 3 robots I'm working on, none completed yet. I can't complete the robot because I don't have any more servos. I ordered some more servos, but why wait for a delivery truck when I can build another robot with the components that I do have? As they say, one monkey don't stop no show. I actually printed out some parts right here for testing the base. This is much smaller than the other. I'm gonna print this new version of the robot with this filament. But I wanted to show you something real quick that I just discovered. Designing the robot right here inside the Blender program, and I have everything on the slicer file for the legs to be printed. This is the preview, and right when I go here, I did not even know this existed. I can actually see the live feed. Wow, that is so cool to me. I'm sure a lot of people already discovered this and figured this out, but I did not know this was a thing. And you can see the temperature and everything down here. I can even control the light up ahead. If I hit this, I can turn the light off. I'm sure the light is off. And here the light is off. I'm going to turn the light on manually. Wow, that is so cool. I'm watching this Tubi movie. It's called Life Cycle. It's about an AI robot. He's trying to become a real boy. He was designed to do that. I don't know. But while I'm watching this movie, I can click over and check my printing and see how that's going. Did you know I can watch the live feed of my 3D printer while being away from my 3D printer? That's way too much power for one man to hold. Look at that. It's translucent. I have to buy more of this. I like this. And did you know that translucent filament was a thing? That's insane. Anyway, back to the disaster. Go back and check on the design. All right, so this is my test rig. I got everything set up just to test the rig and get everything going to write the code, because this is not going to be the permanent build. I'm going to be transitioning onto the ESP32 cam module. Yes, buddy. I'm going to be transitioning to that. But in the meantime, I want to get all my code working properly. So I want to see if this long servo can hold all this weight. And it rotates that way. See if it rotates back. See, it's not strong enough to rotate back on its own. Have to implement something in the design. This, on the other hand, is working fine. So this will be the face. So this is sort of like a mini version of that one. I'm gonna test this and get everything functioning. See if we can get this boy to stand and to walk and do some backflips and cartwheels. So in the previous video, I removed the joint in the neck articulation because I was having issues. Well, the same issues have shown back up, but this time it was in the foot. Yeah, he's struggling carrying his head. So I'm going to reprint, adjust this, and see if I can't find a solution. Turns out that I'm frying my servos. And I'm going to fry a lot more servos because that's just what I do. One slight error in the code and the computer can become confused and send unnecessary voltage to a blocked servo. And then boom. So I'm hard at work here trying to get this robot to stand. So I want to show you something. When I go plug it in, all right, so now it stands, right? I have some commands. I can make it stand, sit, boom, full stand, right? Now, in order to get my walk cycle going, I understand that you need to balance. I've written that code for it to balance on one leg. I'm going to hold it so it don't fall. And I press the code for it to raise one leg. It raises the leg, but this leg also wants to fall. If I go back and hit the code to raise the right leg, which is this leg, it raises this leg, but then this wants to bend as well. So I was thinking that maybe it's my power bank. Maybe this isn't giving it enough power, so it's causing those to lack. I removed this and decided to plug it in to the power bank on this robot, which is much bigger. It's a little more powerful. So I plugged it in. Once again, I'm gonna hold it and try to raise the leg. The leg raises, but it wants to fall over again. So it's the same exact thing. So this tells me it's not a power issue. It's actually an issue within the code. So upon analyzing the code, I'm learning that the code that I have written to raise one leg is actually affecting this servo, and to raise the other leg affects the other servo. I'm affecting both legs, and this is so cool to me because you have to have everything exact, the right casings, the right, everything has to be on point because it's going to do what you tell it to do. And if you have anything off, it's going to do that as well. So when you find an issue, you thinking something's wrong, and it could be something wrong with your hardware, but it could be in that code. You probably told it to do something, not knowing, and it did that exact same thing. So now you have an issue. So I'm going to adjust this code to isolate these and just affect one side, and let's see what happens. I have adjusted the code. Raise the left leg. All right, down. Raise the right leg. Down. Right leg. Down. The left leg. Down. Everything's functioning properly. Now we have to figure out the weight distribution, the balancing issue. I also have a function where the head right here is able to lean side to side. So boom, it can go there, it can go straight, all the way to the left, slightly to the left, straight, slightly to the right, all the way to the right. Everything has to be precise and exact. One error, you can throw everything off. I can't even remember where I put my phone half the time. So you can imagine how much of a challenge it was for me to keep up with all these pins and servos. Getting together the posing of the leg. So I got functions for the foot. Function, other foot. Got all poses. Also, he still stands. Lean back. Too far. Hopefully that's not an issue because he keeps leaning forward and staying forward. After I resolved the issue and figured these things out, it was time to construct the walk cycle. Always good to pull out the handy pen and paper to help get an idea of what's going on. So I'm going to draw a walk cycle. I have a background in animation. I'm going to see if I can't apply those skills to this to get this robot to walk. I'm mapping everything out. This is a starting pose. Back pose, we need a passing pose, stationary pose, passing, and a pose, right? Does that like a good walk cycle? It starts at the furthest back, begins to come forward, straight, stationary, begins to move, and the furthest it can go frontwards, forward. So that's the walk cycle. So I'm going to go ahead and plug in each angle, each number that I have for this thing. Oh, this robot. I'm going to plug in. Man, I've been working all day. My brain, it's not working. It's not working. So bear with me. But I'm going to go ahead and plug in all these numbers here on this pad, on this paper. This is what our code is looking like. So as you can see here, I got stand, rest, sitting, left leg forward, right foot forward, left leg forward. This is like the passing, right foot forward and D. Then this is straight, left foot. This is the stationary, left foot stationary, right foot stationary. So I got all the commands and arrays for each leg. And then I got arrays and commands for the waist. Same with the pivot, the rotation of the hips. And these are just placeholders for like if I want to do a quick test of a servo for like these different degrees. So that's what we got. All right, so I'm starting to map out the code for each foot. So for this pose, it's going to be left foot straight, right foot straight, waist straight. So that's the stationary pose. So for the next pose, it's going to go into waist, pivot left. So it's going to lean left like this. That's pivot. So it pivots left for weight distribution. Then left foot forward, left foot begins to move forward, etc., etc. Pivot left, left foot all the way forward. This foot starts to move back. So that'll create the walk cycle. So I'm going to finish plugging these in. Probably need to take a break first and then I'll plug them in. While constructing the code for the walk and the posing of each leg, I ran into a major problem. And I mean a major problem. I'm talking end of the world type stuff. See, it's still leaning forward instead of sitting back like that. All right, so we got the robot, and upon hitting the, let's see, down, up, straight, down. You see how it leans forward like this? It's supposed to sit back like that. And when I hit down, up, it's leaning forward. It's supposed to sit like that. So because I don't like that, I gotta scrap it. I want it to sit straight up, so that's bothering me. I don't want it, and I know that's gonna cause problems down the line, getting it to stand up straight, and it constantly leans forward. Ooh, see, like that. It just leans forward. It won't stand all the way up. And honestly, I have to scrap it. That's the only solution. This robot has been taking me such a long time to build because I'm sort of a perfectionist, as some would call it. Or maybe I have some symptoms of the obsessive compulsive disorder. You know, I will work on something and keep working on something until I get it the way I want it to be, but that often results in me either overcomplicating it or breaking something. When sometimes the best move is just to simplify. I'm always looking at, can I make it better? And with that being said, we have to scrap it and start over. It's the only way.